All right, so next we're going to take the two skills that we just learned and apply them to solving for all of the missing pieces of right triangles. So we'll start off with a first example. We'll do two examples of this, and then you'll get to practice doing some similar type operations. And here we want to find what is x, what is y, and what is z. And here, actually, I can write this maybe a little bit more clearly. That's supposed to say 60 degrees. Not much better, but hopefully you get the idea. Okay, so first things first, let's look at our angle measures. So if we see here, we have a 90, we have a 60, and we have an unknown. So 60 plus 90 plus our unknown equal 180 degrees. So we got that from our properties from above. So we'll put these two together. So 150 plus y equals 180. We can get y alone. We'll get y equals 30 degrees. Next, we're going to have to use some of our trig properties to find either x or z. So in this case, let's say we focus on our 60-degree angle. And based off of this, we can identify some things. 22 is our opposite side. X is our hypotenuse, and z is our adjacent. So if we want to solve for x first, we can use sine of 60 equals opposite over hypotenuse, so 22 over x. And then now we can punch some of these values in and get an answer. Best thing to do here, make this a proportion and cross multiply. So we'll get 22 times 1, or just 22, equals x times the sine of 60. And then we want x by itself, so we're going to divide by sine of 60 to simplify that to a value of 1. If we do it on one side, we have to do it on the other as well. So we're left with x equals 22 divided by the sine of 60, which we can simplify to 22 divided by the sine of 60. We should get an answer here of 25.4. All right, so once we are there, I just want to double check. Always good to make sure that your calculator is in the correct units here. So if we do the sine of 60, we want to make sure that we are in degrees. So we'll do sine 60, and I'll do this again. That should give us 0.866. Awesome. So we'll have 22 divided by 0.866, and that'll help. All right, so again, always good to like double, triple check, make sure we're in the right space there, because otherwise it definitely could lead to some wrong answers. So 25.4 is our x value, and then the last thing here, look for z. So you have a few choices here. If you want to go back to a trig function, you absolutely can, but think about what we learned above with the Pythagorean theorem. So we know that our long side here is 25.4, so we can take 25.4 as our c value, and we can use a squared plus b squared equals c squared. So here will actually be z squared plus 22 squared equals 25.4 squared. So we can go through and evaluate these things. So 25.4, we'll take that and square it. We should get about 645.4. And then we'll take 22, we'll square that, get 484. And we can subtract 484 from both sides. We'll get 161.4. And then last step, take the root of each of these. So we'll get z equals root of 161.4, or 12.7. So go back to the top, c is 12.7. So that's the idea here when we're working through these examples, is we can use Pythagorean theorem, we can use trigonometry, and we can also use the angle measures from inside the triangle itself. So try to use this one as an example for how to go through and basically calculate each of those things. So we'll do one more quick one, and then we'll call it good. So similarly here, solving for x, y, and z. So first step for y, 52 plus 90 plus y equals 180. Put these two together. Subtract to isolate your variable. We'll get y equals 38 degrees. Next, we can use some of our trig functions. So maybe we can use sine again. I like sine, I'll be honest. That's why I use it all the time. No other reason than the fact that I just like it. So if we identify 52 as our angle, we do the sine of 52. That'll be opposite over hypotenuse, so it'll be x over z. And in this case, I like sine a lot. That's a good example of a function we actually can't use because we have two variables here. We have both x and z. So no dice there. We have to use a function that involves our 6, something that we do know. So maybe let's change this around. We can use cosine instead. So if we use the cosine of 52, that'll be adjacent over hypotenuse. So that'll be 6 over z this time. So we can go ahead and punch that in. So cosine of 52. Have our value for that. And then start to use our algebra to solve. So again, cross multiply. So z times the cosine of 52 equals 6. Divide by cosine of 52 on both sides. We'll get our z answer of z equals 6 over the cosine of 52. Or we can put that in as 6 over, do it all in the calculator in one step. Make life easier. 9.75. So we have y, we have z, and then now we can finish up with the Pythagorean theorem. So we have x squared plus 6 squared equals 9.75 squared. So we can take that, let's see, square that answer, go from there. So how about, say, 95.06. We can round that up to 95.1. 36 and x squared, subtract 36. And we'll get x squared equals 59.1. And we'll take the square root of 59.1. All right, and there you have it, solving for missing parts of triangles using old skills from geometry combined with some trigonometry from right now. All right, so some more opportunities to practice coming up on the next page. Again, take the time, go through these questions.